Hello everyone, I'm going to discuss in this video the law of sines. Alright, so we see it stated below. It's for oblique triangles, and what an oblique triangle is just a triangle that's not necessarily containing a right angle as pictured on the screen here. Alright, and we're assuming we have across from angle capital A, which we have in the lower left corner here, side length little a, and likewise across from angle capital B, which is shown outside of the picture or outside of the corner of that triangle little b, and likewise for C. The law of sine states that these following ratios are equal, and it's given in two ways, and the difference between these is that it's just reciprocal. So if you flip the first statement over, you'll get the second statement. Alright, one thing to point out too is that this really says three different things. That sine of capital A over little a is equal to sine of B over little b. Likewise, the first quantity is equal to the third, and the second quantity is equal to the third. So when we apply this, we're not going to have a triple equal sign like that. We are going to just take the given information and have one proportion equal to the other. Alright, again, whether we use it in the first format, which is kind of what I'm more used to, versus the second, it does not matter. We'll get the same results in either way. Alright, now I'm going to go through just a quick derivation of the law of sines for one of the equals, and then after that we'll get to some examples. Alright, so to apply that, we're going to use right angle trig. By looking at this oblique triangle here, we're going to drop a perpendicular straight down, which is going to represent the height of this triangle. Alright, so let's call that H for the height of the triangle. Now I'm going to focus my attention for the moment inside of this left right angle triangle and look at what we can glean from that. Alright, and if we look at that lower left corner, which is angle A in it, across from that angle we see side length H. Again, this is now a right angle triangle, so we're looking at this left right angle triangle. And if we just write down from right angle trig, sine of the angle capital A has got to equal opposite over hypotenuse for that angle, and that in that right angle triangle, the opposite side length is H, the hypotenuse side length is C. Alright, and if we multiply both sides of this statement by C, we would clear this fraction out, and we end up getting that H is equal to C times sine of the angle A. Alright, and in a similar fashion, let's look at this right angle triangle on the right side of our height, and if we perch ourselves in the lower right corner and just write down what sine of the angle capital C is equal to for that right angle triangle on the right side of the height, its opposite, which is H again, over the hypotenuse. The hypotenuse for that right angle triangle, again the one going to the right side of the height that I dropped down, is side length capital A. Multiplying both sides by A again, we would get H is equal to A times sine of the angle capital C. Alright, now I'm going to take both of these quantities and just set them equal to each other. Right, so we have H is equal to little c times sine of capital A, and H is likewise equal to A times sine of capital C. So let's write that down below here. So we have those two things. Alright, again it was C times sine of capital A and little a times sine of C. Either way we write that down, we're going to have something like this. Alright, and then we also had H was little c times sine of capital A. Now setting these two equal, we have A, let me do this the other way. I'm going to do C times sine of capital A is going to equal A times sine of the angle capital C. Alright, now to get the result we see in the box, all we're going to do is take both sides here and divide both sides by A times C, assuming A and C are both non-zero. On the right side, the A's cancel out, the factors of A cancels. On the left side, the factors of C cancel, and then we get our result. It says sine of capital A over side length little a is equal to sine of the angle capital C divided by the side length little c, which is one of the equivalences we see up in the table. Alright, so we're going to be applying this in a number of scenarios, and we'll get to an example right now on the next page. But again, if we look at version 1, version 2. Each have their benefits. The first one I'm going to probably use more often than the second just because it's the way I learned it, but they're equivalent to each other. They're just reciprocals. All right, let's look at an example. All right, now this one I have up at the top of the screen, ASA. That stands for angle, side, angle. What do we mean by angle, side, angle? What's the given information in this triangle, and how are we going to use the law of sines to determine the missing information in the triangle, which is mainly the two sides in that missing angle? We see we have one of the angles and the side and then the next angle. All right, so if we think about going clockwise or counterclockwise, we're seeing an angle, then the side length, then the other angle. That's what the ASA, or the angle side angle, means. All right, now let's go through and determine the missing information here. All right, now we know two angles for this triangle. To find the missing angle, we can just take these and subtract the sum of those from 180, or subtract each of them from 180. If we do that for this triangle, all right, you take a calculator and compute it, it's going to be 39 degrees. So this angle right here is really easy to find. All right, we didn't need anything special about that. All right, we did not need the law of sines. We have two of the angles. To find a third, we just subtract those from 180. To find these missing sides, we do need to use the law of sines now. So let's start with the side length A. And to find A, we're going to have to use this equivalent. Sine of capital A over little a is going to equal sine of capital B, over side length little b. Now, plugging the numbers that we have in the problem, we've got sine of the angle capital A, and I'm just going to mention here that they have alpha in the textbook. That's what I'm calling capital A. They have lowercase b, which is beta there. All right, and then this is the side length, or the angle capital C, sorry, 43 degrees. But I'm going to use capital A, capital B, capital C. All right, so capital A, that angle is 98 degrees. I'll leave the degree symbol off. We don't know side length A, so we're going to leave that in. Now, the side that we know is 22. That's across from angle B, so we need to put in sine of that angle, which is, again, 39 degrees. Now, we need to solve this equation here for A. All right, and multiple ways we can go about this. What I'm going to choose to do here is to do cross multiplication. If we have two fractions equal, then their cross products must be equal. So if I multiply A times sine of 39, that must equal 22 times sine of 98. All right, now from here, what we can do is just simply divide both sides by sine of 39 to isolate the factor A on the left-hand side. And now we've got that A is equal to 22 times sine of 98 divided by sine of 39. I guess is in degrees. So if we're using a calculator, do this in degree mode. All right, now I've computed this already. You can double check it. It comes out to 34.6181 if we round it to 4 decimal places. All right, so we've got one of the missing sides. To find the other one, we again have to apply the law of sines for this example. We cannot use the Pythagorean theorem because we do not have a right angle triangle here. All right, so we're going to do a very similar thing with angle C and side length C. All right, so very similar, and let's stick with using side B because we know that one. So it's angle sine of capital C over little c will then equal sine of capital B over side length little b. And I'm now plugging these numbers in here. We know from our figure, scroll back up to it here, the angle capital C is 43 degrees. We don't know the side C. So we're going to put in 43 degrees for capital C. Put down side C, leave that alone. Is then going to equal sine of 39 degrees divided by 22. All right, I'm not going to show the work for this, but very similar. Either cross multiply or reciprocate both sides and then multiply by sine of 43. Either way, we're going to get that the side length C is going to come out to 22 times sine of 43 degrees divided by sine of 39 degrees. All right, so very similar to what we saw up above, except 43 instead of 98. Again, you can compute this with a calculator, and if you do so, you're going to come up with 23.8415. All right, that's a length. What we found was two lengths here, capital a little a and little c. All right, so we could go back up here and label the figure. We found a, we found side length little a and side length little c, and that was all we were asked to do in this problem, which is to solve the triangle. And solve the triangle means find all sides and all angles. And I think for time's sake, I'm just going to stop this video here. The next video, we're going to look at another example, another couple examples where we're given two sides and one angle and using the law of sines.